Friends, good afternoon. I'm sorry I am invisible to you, probably because organizers thought that this is a webinar on electricity and electricity is invisible. So let the moderator also be invisible. So I am sorry for that. There is some technical glitch on that. So I'm really grateful to the organizers for inviting me to chair and moderate this session on power quality and electrical safety in buildings. I'm very happy to note that CEA, in association with EIS and HIMA and International Copper Association, have already successfully organized 3 virtual meets under National Electrical Safety Awareness Program. In fact, Mr. Manas Kundu and I have been passionate about two subjects, power quality and electrical safety, ever since I came in contact with Mr. Kundu, and we rather had a committee in ERC, which I headed, on power quality, and we had given a report on how power quality regulations should be made and implemented in India. So that gave way to the state electricity regulatory commissions to go ahead with power quality also. Power quality was not given due importance in past, primarily because the emphasis initially 2011-12 was on availability of power. Once the availability was ensured, I mean, the adequate generation capacity came into being, the next aspect on which the emphasis was turned towards making reliable power available. Reliability. First was availability, then making reliability. That means to ensure that 24 by available at appropriate voltage level, etc. So now is the time. In 2016-17, we decided that power quality should be given its due importance, and that's how Mr. Kundu and I have been associated with. He has rather made it a mission to take this power quality system requirement to different parts of the country, and I'm very happy that in this context he has they have organized this webinar. So why power quality was not given its due importance? There are many reasons, that like lack of awareness and capacity to understand issues and challenges associated with quality of power, restricted availability of technology in detecting and overcoming such challenges, and absence of regulatory intervention. Power quality is something which has to be ensured, which have to be implemented. There have to be incentives and disincentives for maintaining power quality. So that's missing in India. We have some reliability in DCs like SAIDI, SAFI, MEFI, etc., which have been regulated by different state regulatory commissions, but these are not strictly implemented. I don't know of a single distribution company having been penalized for not maintaining this performance or standard reliability in basis. So similarly, power quality there are some power quality regulations which set up by CEA and by some electricity regulatory commission, but these are not implemented. Now is the time that these are strictly implemented, and this webinar is very timely. Now, coming to its linkage with electricity safety, electrical safety, which is an equally important issue in country like India, where there is general indifference to safety norms and alpha high attitude is quite prevalent. This leads to huge losses in terms of human lives and loss of equipment every year due to electrical accidents. Now, power quality in buildings will become a major issue because large buildings and commercial establishments have a huge amount of non-linear loads like PCs, LEDs, inverter-based equipment, etc. So the power quality, maintaining the power quality will be a big issue. Otherwise, there will be both technical and financial losses to everyone. That's why we feel that the country should come up with power quality standards at the earliest, and these should be quickly implemented by the State Electricity Regulatory Commission. I would say there is one more component of not power quality, I would say. It's a quality of construction also, electrical installation in building. So while power quality per se is important, equally important is the quality of electrical systems, equipment in large buildings, like proper earthing, proper wiring, use of standard protection devices, and ensuring that these devices work, firefighting, etc., etc. Another aspect which is not connected to today's webinar but is important while designing buildings is energy efficiency. I hope Dr. Venkatesh, who deals with the energy efficiency also, will touch upon this part also, although that's not completely electrical subject. In a building construction, a lot of other aspects have to be seen to ensure proper energy efficiency. And for that, BE is easy there. So I feel that electrical safety, power quality, and to some extent energy efficiency are linked together, and uh, it is very appropriate that today's subject is on power quality in large and its effect on safety in large buildings. I am sure today's papers would dwell on all these aspects, and we will be able to better understand the issues and their solutions. From today's presentations, we'll try to track power quality factor endangering safety, forming a cause for an electrical accident and damage to the equipment, further leading to downtime. We'll also learn on what are the design DNA that today's designer must consider to maintain high PQ environment in buildings, and how and what steps should be taken to ensure higher power quality. In today's webinar, we have three presentations by eminent speakers: Mr. N.K. Jain, of N.K. Jain Consulting Engineers, Mr. Rajen Mehta, MD Effici Energy, and Dr. Venkatesh, Vice President TDK Electronics. I request each presenter to finish his presentation in 20 minutes time so that we are able to finish this webinar within the designated time. So shall we start with first presentation now? I can introduce Dr. Jain if
Sure, sir, sure. Please go ahead.
yeah, Mr. Jain, you are already there. Yes, Mr. Jain, Mr. N.K. Jain is the owner of N.K. Jain Consulting Engineers. He holds a bachelor's degree in electrical engineering from BITS Pilani and master's degree from IIT Mumbai. He is a life member of Indian Nuclear Society and fellow life member of Consulting Electrical Engineers Association of Maharashtra. He has professional work experience of more than 47 years in designing, installation, testing, and commissioning of electrical distribution system and other utility services for industrial, commercial, and IT facilities. In that respect, he is senior to me. I congratulate him. Yes. He is running his own design consultancy firm by the name of N.K. Jain Consulting Engineers in Mumbai, and has successfully designed and executed more than 500 projects comprising of IT facilities. Now I request Mr. Jain to make his presentation, please. Kindly stick to the time schedule.
Thank you, Mr. Bakshi. We will straight go to my presentations. Power quality and safety in buildings, more specifically in high-rise and commercial buildings. Now, I believe that all people in audience are either electrical engineers or related with the electrical industry in one way or the other. And therefore, I'm sure that all of you must have come across these aspects in your life, must have dealt with these aspects, especially the safety of electrical systems in the buildings, and many times even the power quality issues. So this presentation is basically a structured compilation of such aspects as to how we can, from the end to end, we can have a look at these aspects, and then in the end I will stress upon how these aspects can be minimized. The power quality and the safety issues can be minimized if a system is well designed and well executed. As Mr. Bakshi had also touched upon in his talk, that even a bad quality of execution could lead to safety issues and bad quality. So in electrical systems, actually everything finally blows down to a bad quality and safety issues, whether it is under designing or bad executions or any of these aspects. So it's very important that these aspects need to be paid attention now that as Mr. Bakshi said, we have enough power in the country, and there is not much of a those pre-designed power cuts are no more there. So it's time that we pay our attention to the quality and the safety, and we must bring down the accident rate of due to electrical shock to as low as possible in any other advanced countries. We will now proceed with my presentation. Yes. Now let's see what is actually power quality and how do we define power quality. I mean, of course, we all know that this is a bad quality, or I got a surge, or I got a voltage dip or something. And every time many people attribute all these things to power quality. But let us see what is basically a power quality issue. You see in this slide, there are various kinds of power qualities are shown here in the form of a sinusoidal wave. We have transients and all harmonics, which is shown in the first wave, and the wave would look like that. We have voltage fluctuations where you can see the voltage going high and low and going out of the limit. That's also a power quality issue. Then there are frequency fluctuations. Sometimes the frequency is 50, sometimes goes to 49. Although now we have a national grid in India, which is, even the regional grids are all connected together, and the stability of the frequency is quite good. But yet in isolated power systems like generators and other places, sometimes these issues could be experienced. Then we have micro cuts, which are there for a fraction of a second the power is not available, and these are generally less than 10 milliseconds, which is almost like half the cycle. Such micro cuts also are an issue in power quality, but mostly it is not felt by most of the loads, so they are not a cause of major concern. Then we have these power cuts, which used to be, which in our country everybody is familiar with the power cuts. So that also is basically a power quality issue. And when none of these are present, and when you have a perfect power, then we have a sinusoidal wave, which is shown below in the last, and that's what we call a good power. Why power quality is important in high-rise buildings? See, two main reasons. High buildings have long cables, therefore higher voltages, and cables get heated up because of the IR and I square R. Then there are harmonics because of the type of loads in the new buildings. Most of the new building, high-rise buildings or even commercial buildings, as Mr. Bakshi also said, these are having non-linear loads, a lot of IT loads, computers and servers and related things. And these non-harmonic loads are actually the harmonic rich loads are IT loads in such buildings. And these are likely to overheat the transformers and cables which are used in that building if the harmonics levels reach a very high level. And both of these aspects, the voltage drops or rather large voltage drops and these harmonics, they increase the chances of fire in the building, and therefore it's an utmost cause for safety. uh, Fire safety in sustainable high-rise buildings is what we will look at it now, because ultimately a good safe building is results in a sustainable high-rise buildings. Otherwise you have buildings, and many times you see various videos and on news channels, so this building gutted in fire and that building got gutted in fire. So a good designed electrical systems and a safe electrical systems converts the building into a sustainable building, and therefore it is of utmost importance in any high-rise building. To reduce the fire risk, what we should do, we should have high quality of design of electrical systems. We should also have high quality of maintenance of that system once it is installed and commissioned. I'll just show you an example of a cable duct in a high-rise building which I had come across in my long career. And this is a building which is existing in Nariman Point in Mumbai, where this is how the cable duct, which was these buildings were designed sometime in 1973, 72. Now imagine, after so many years, now the buildings have assumed a different role. There is such a lot of IT load in that building. The owners and the occupants of the buildings have changed multiple times, and they had only one duct, and everybody was passing those cables through that duct. To start with, this duct had only five, six cables in the early days in 1973 when it was commissioned. Today, the whole duct is full of cables, and you see those green hose-like things. Along with the power cables, even the fiber cables and the data cables are passing like this. And these ultimately give rise to, when I was called upon in this, there is about a 10-year-old assignment that I was called in, and I was shown this. When the door was opened, I could not stand in front of that duct because the heat emanating from these cables was so high that I had to take 2 steps back and then speak to the gentleman who was speaking to me. So these are the kind of things that can happen in a badly designed buildings. Of course, fortunately, it has been a long time since 1970s when such kind of buildings were started being designed and constructed in India, initially in Mumbai and then in many cities. And of course, hopefully now the buildings are designed much better, where they have much more ducts and things, other services properly designed, so which don't face such issues. What is the solution to this? A rising bus duct is a must in any high-rise building. You all must have heard of a rising bus duct, where it's nothing but a bus bar kind of a thing. So instead of running so many cables, you just run a single bus bar or a bus duct right from bottom to top and tap it anywhere, so that you don't have so many cables going, and the duct is free. It is designed for a particular bus duct with all the spaces all around, and it remains that way. So it does away with most of the heavy cables that I showed you in that slide. In many states where you must have been involved, and you must have been associated with works in many states, especially the southern states, it has now been made mandatory by the electrical inspectorate there, what they call it as CEG there, that they don't allow any high-rise building with cables going like the way I showed in the duct. All the vertical cables have to be in the form of a bus duct rising. But yet there are people who are not following these. There are many, because after all, an electrical inspector is not like a traffic cop where he's checking everybody. So it happens and people are little irresponsible. But by and large, if these kind of bus ducts are followed, that heating problem would at least not be there. And we should prefer sandwich type of bus duct, where the chances of failure of conductor to conductors are less, and these occupy a much smaller space, and sandwich kind of bus ducts can be managed with a very smaller size shaft going all the way. We should also, as far as possible, use copper bus ducts and copper cables also, because copper bus bars, to reduce the power losses, because losses in copper is much lesser than aluminum, and lesser the losses, the lesser the heat generated, and accordingly that much percentage reduction in likelihood of a fire taking place in that building due to this kind of heat building up due to the electrical system. Sandwich bus duct installation is this is an example. You can see how it's a graphic which shows that how these bus ducts are reason. You can see 1, 2, and 3 risers. On the ground floor there is an electrical room with transformers and other things, and these risers are coming, and all the loads at every floors are tapped from this, And other than this, there are no other cables running up and down except, of course, the communications and the data cables, which don't produce any fire or no heat. Then you have power quality issues. So how to overcome power quality issues? The quality issues that we have discussed in the first slide, where I had shown that there are various kind of power issues are there. One, this was all about safety that we were talking, but of course this kind of heating can also give to power quality issues. But majority of the power quality issues that we had discussed, we will discuss now how they are taken care of. So power cuts, which we are familiar with, all of us, for the last so many years in our country, everybody knows, and everybody also knows how to take care of that. And so people used to have generators and UPS, and of course inverters. Although Bombay is not familiar with inverters, but all other cities and all other states in India know what is an inverter. Then there was I had shown you that what are the micro cuts, which are less than 10 milliseconds, and of course no action needs to be taken, because those such kind of cuts, they do come in power supply sometimes, but they are of not much consequence, because most of the motor loads and heating loads and lighting loads do not get affected. Even IT loads may get affected occasionally, but as long as it is less than 10 microsecond, even the IT load continues. But if it goes beyond 20 milliseconds, sometimes the computer PC or the server will drop down. We have voltage fluctuations, which is also a very familiar thing. I think everybody in the audience is aware about and familiar with that. And of course, we know how to take care of that. We have been using stabilizers and automatic voltage regulators. Hopefully, the need for that is now reducing, but yet these problems do continue, because the country has only overcome the power shortage problem so far, but these kind of problems have never been overcome so far. And all the distribution companies are not yet paying attention. As Mr. Bakshi said, that nobody has ever been, no distributor has ever been penalized in India because of low voltage or high voltage or any of these kind of things. I wish these things come in future. Then frequency fluctuations do not affect too much. It can affect some motors and some very very precise drives, but if people use UPSs for such situations, and UPSs do work on a perfect frequency, whatever you desire or whatever you set, and if it is an AC output that you want, then 50 cycles is exactly what they give, which is required in our country. Then the transients are there. These have to be taken care by surge protecting devices and transient voltage surge suppressors, and most of you also may be familiar with these. Very important to be used in any IT installation, because while voltage fluctuations or a voltage variation is nowadays not so important in IT loads, but these transients and these surges, voltage surges, are very very important, and they are very damaging. 30 years ago, even a voltage fluctuation was very damaging to electronic items like TVs and other things, and then came the computers, and we started using UPS, where we are giving 230 volt plus minus 1 volt perfect supply. But over the years, the manufacturers of the IT equipment and electronic equipment, and nowadays the LCD TVs and LED TVs and all, they have also improved. So they have increased their voltage window, input voltage window, to a large extent. And today, if you give 220 volt or 210 volt or even 230 volt, 240 volt, there is no problem. The TV will not get damaged. But still, most of the HVAC equipments, most of the air conditioners, which countries using more and more, and the sophisticated inverter-based air conditioners and all, they are still designed with very accurate power supply, and there the voltage stabilizers and AVRs are very essentially needed, because without that the systems either shut down or it gets damaged. And of course, we are all familiar how the equipment suppliers and the manufacturers will blame that you had a bad voltage or you had a bad power supply, and therefore I will not respect my guarantee, and I will not give you a free replacement. So these things have to be paid attention to. They're very important. The last thing, which is my harmonics, which I will assign a large part of my talk to this topic. Harmonics are something which is not being given by the utility company, although some other producers are producing and then via utility companies travels to us. But most of these harmonics are actually being produced by the consumers, and then they have to be managed and mitigated by the consumers. And actually very soon electricity distribution companies will start penalizing for injecting harmonics into their system. Like today they are penalizing the voltage of the power factor. And all of these aspects that I have shown there, they can all be taken care if you have a very good designed electrical system. And of course one has to ensure that it is also executed in a very good manner. Now let's see what are the components when we go to design a good electrical system. What are the components that are there in a good in a commercial building or a high-rise building in a power system? So you have on the left side a transformer power coming in, maybe 11 kV HT power, and then on the right side you have a generator, and then you have in the center you have this changeover switch, and then you have a distribution system here. So you have on the left side this lighting and air conditionings, and then there are these computers, and you have some telecom equipments, and if it is an industrial building or could be a pharmaceutical building, there could be some electronic load or some PLCs there. So this is generally a composition of an electrical system of any building, whether it is commercial or high rise or any large building, or rather modern large building. Typical load in modern buildings are microprocessor based elevators and escalators. We have HVAC loads such as AHUs, pumps and compressors fitted with variable frequency drives, VFDs. Then we have light fittings with electronic ballast now, and of course now even those are gone. Now we have LED lights everywhere, and LED lights also have an item called driver, which is nothing but an electronic device. Then we have BMS systems such as fire alarm systems, CCTV systems, access control systems. All of these are electronic, all of these are IT. Then IT equipments, desktop PCs, servers, switches. We have UPSs and DC power supplies. UPS is a very unique equipment. It takes care of harmonics and it also gives harmonics. So it has to be, we will discuss about it, that one has to be very, very careful while selecting an UPS, that while it may be taking care of the harmonics which are coming from computers or some other devices that you have. I'll elaborate later. We have heavy equipment such as projectors, LCD TVs, audio video systems. All of these are giving harmonics and injecting harmonics into the system. And what are the effects of these harmonics? Harmonics means higher frequency. Harmonics, general frequency of our power is 50 cycles per second. In an harmonic kind of a system where harmonics are prevalent, we have voltage, we have powers, the sinusoidal waves which are having higher frequencies than 50. It could be 100, it could be 150, it could be higher. So various magnitudes of that frequency signals superimposed on the main frequency are called harmonics. It has skin effects because the higher the frequency, the impedance rises higher, and the current tends to flow on the surface. So it can give rise to skin effect on large diameter cables. I remember about 20 years ago when I started my consultancy practice, I had gone to Bangalore, and one of the gentlemen invited me there. One of the customer invited me there to show. It was Infosys, I remember now. It was very early installation of Infosys, and he took me to his UPS room and he showed me that, look sir, so many cables we have put that used very large size 300 square single core copper cables, and they were lying on the floors. And he showed me that the entire cables had some kind of a blisters on the surface insulation. Entire insulation was blistered everywhere. And of course I wasn't aware that time so much. So of course I told him it's due to heating. But later on when I was going through and I was studying these harmonics, I realized that entire cable had got burned due to skin effect. On the outer side of the cable the heat was more and the entire insulation had blistered. So these kind of things can happen. Then we have higher neutral current if the frequency is 3 times, which is 150, which is what is called a triplen harmonics or third harmonics. If that is prevalent, then you have a lot of neutral current because RY and B doesn't get cancelled, while all other frequencies, and the predominant main frequency, the RYB and cancel each other, and we have a zero neutral current ideally. But when we have third harmonics, there is a lot of all the three phases currents are getting added in the neutral, especially the harmonic currents, and we have very large currents flowing in the neutral. And our philosophy, the so old philosophy of 3.5 core cables, which we are so familiar with, doesn't really work there. And if you are doing any distribution, especially for computers, from the distribution dB onwards, or even the output of the UPS onwards, you need to take care that you put complete 4-core cables and not 3-core. There was time initially when I used to put 5-core cables which with double the size of neutral, but now of course things are not so bad, so even a full neutral would take care of that. Then we have malfunctioning electronic sensitive electronics because of these kind of harmonics. We have derating of transformers and generators because of these heatings and impedance increase and heating caused in the transformers and gensets. A 1000 kVA transformer can no more be used as 1000 kVA. It will have to be used as 700 kVA transformer. And the same is with generator, or even little more, because generators are still more sensitive to harmonics. So these are the problems that all are faced in the industry by harmonics. Some people are aware and finding mitigations and solutions. Some people are just not aware and every day facing problems and load drops. Early aging of equipments happens because of this overheating. The motors will not last long. They'll have to be changed sooner than if you would have changed a motor after 10 years. Maybe in this case 7 years you'll have to change a motor. Higher power factor, of course, again because of this, the power factor which today everybody is trying to maintain, a unity power factor becomes difficult unless you use very specific um, equipment. We will come later to that, and to bring your power factor to unity, because now these electricity boards are penalizing in a very big way for any power factor which is lower than unity. Effects of harmonic, that I was explained everything. We have how to avoid these harmonics now. Having discussed that what problems it can cause and what you can do, I will now focus on what you should do so that we do not have these things. How do you design a system so that we don't have the problem right in the beginning? Prevention is better than cure. So design features. There are three or four ways by which you can minimize these. One is that minimizing at the source. Second is you isolate and arrest them. Third is you filter them and absorb them, or you oversize your cables and equipment, which is a post facto. You already designed the systems and you have nothing else to tweak with, so you just oversize your equipments and cables. At source, how do we minimize? Proper specifications and selections of equipment is the most important thing. UPS I was talking about, and VFDs, we must ensure that these UPSs give you less than 5% current harmonics on the input side, and it gives you a power factor which is higher than 0.95 on the input side. This slide was prepared by me about 5-6 years ago, and I've been using it. Today I have changed this, especially I work for large data centers, so there it is very important for me. So there I have changed the specifications to THD less than 3% and power factor less than 0.99. We have made it so stringent that we don't buy any UPS which is not conforming to these standards, because you buy UPS on one hand and to take care of the IT equipment, but if it introduces such a large harmonics in the systems, we have another problem on hand. Then we have servers. Earlier the servers used to be very bad in harmonics, but fortunately for last 7-8 years even these things are not bad, and now all the servers are basically, when you buy a new servers, they are giving this less than 3% and less than 99.99 power factors, so there is no problem. And of course all servers are always protected by UPS, and I'll show you later in the slide that UPS is a firewall for harmonics. This is all servers are this IEC 1000 compliant. Desktop PCs are not so, manufacturers are not so worried about, I mean, they have not paid attention to that, and yet they are still generating harmonics. But I would advise that you should buy branded PCs where the probability is less. But yes, PCs would generate harmonics higher than 50% on their input side. Electronic ballast also generate around 33 to 40% harmonics, the early versions and the cheap versions. Later on, we started having ballast which were, highest standard came for electronic ballast, and ballasts were available of less than 10%. And many installations which are old, which actually have not been able to, I mean, everything has not been changed to LED. Many offices are still having those CFL lamps and those kind of T5 tubes where these ballasts are there. And if somebody is in the process of changing this ballast or changing the fittings, please ensure that you buy ballast which are less than 10% harmonics. Then we have TV equipments, AV equipments. Ensure that you buy branded ones. Now we come to isolating and arresting harmonics at source. So we need to use special equipments. One I was saying is UPS. We are putting UPS everywhere in our computers. In every office computers we have UPS. We have centralized UPS and a UPS power supply below every desk. Below every table there are UPS sockets. But nobody is actually aware that this UPS is also arresting the harmonics which are coming from computers. UPS we are putting so that we don't lose power whenever there is a power trip. Our work that we have done on the PC should be saved and our server should not go down. But this UPS is also a very good a firewall. It protects, I mean, it stops the harmonics coming from all the IT equipments. And on the upstream side of the UPS, the harmonics are reduced drastically. Then we have PDUs, power distribution units, with delta star isolation transformers, K20 rated, and all these things. We have special transformers, zigzag, phase shifting, harmonic cancelling transformers. So many are there, and these are being used by various people wherever these are needed specifically. Not that everywhere we need to use them. Dual quad output transformer, where primary is one, the outputs are 2, 3, 4, because you may have sometimes different kind of harmonics and you may want to mitigate. One equipment is giving this harmonic. It happens in industries. One equipment, large equipment in an industry, a machine is having some kind of an harmonics, and the other equipment is having other harmonics. And instead of putting transformers separately, you can put one and give supply to 3 machines from a different secondary winding. Then there are passive and active harmonic filters. UPS and how it protects. See, on the left side we have UPS, which could be specified as 3% THDI, or even 30%. If you don't specify, the fellow will give you a 30% THDI. Of course, that's, I'm talking about third generation UPSs, which are nowadays not so much available. All UPS manufacturers have moved on to a better UPS. But not long ago, 10 years ago, there were UPSs which were, if you had not been careful, you would buy a UPS which is actually giving you 30% harmonics. And since UPS is connected between the transformer and the computers, so this UPS would give 30% harmonics, although from computers you get something like 70% harmonics or even more. But still, the 30% harmonics of a different type would be given by the UPS to the transformer, and transformer would still get heated, because the international law says, or even Indian law now says, that the harmonics that you inject into the grid should not be more than 5%, and you would be penalized, and transformer will get heated. So you have to be very careful while selecting your UPS. Use of special purpose transformers that I was talking about, delta star, which are used in PDUs. Then you have these auto transformers, zigzag. You have isolation, dual output. You have quad output. Various kind of equipments are there. These are all generic things that I'm putting here. Where anybody has a problem, will have to consult a specialist, and he would give a solution exactly suited to your requirement if you face a harmonic issue. Then there are filtering and absorptions. There are passive filters. These are all LC networks, LRC networks, where you can connect them. Every UPS used to have earlier, wherein you whatever input power that is coming, harmonics do not go back, they get filtered here, but these are specially designed for a particular type of harmonics. And then you have active filters, which are not designed for a particular harmonics. They are wide spectrum harmonics they can handle. They are actually harmonic generators. So whatever harmonics are there in the system, when they are connected in parallel like this, they will also generate harmonics, but equal and opposite, and they'll cancel. So this is an equipment which is very frequently used, and most of the panelists here are aware of this. Use of active filters. See here, it's a wave which is coming from UPS. If you had a UPS, which I was talking earlier, and if it was giving 30%, now you want to find a solution, what do? So you select a harmonic filter, put it on the upstream side of the UPS. It will filter out all the harmonics and it will give you a nice sinusoidal wave, or rather it will draw a sinusoidal wave perfect from the grid or from the input side. And this is how these kind of problems can be solved. Then the very standard way of oversizing the cables and double full size or a neutral, double size neutral, then derating of cables, derating of transformers. I told you 1000 kVA transformer, use it as 700 or 500. Generators also same. Use copper cables, the IRs are less, drops are less. The space utilized would be much less, and it will optimize the costly building space. I was doing a study where people used to tell me, sir, your electrical room is very big and reduce the electrical room size. In my early days of practice, I came from industry and I used to have big panels and big thinking that maintenance. But later on, I did a study and I found out that the footprint occupied by my panel is the real space, real estate cost of that space is 5 times the cost of my panel. And therefore in these buildings, commercial buildings, these kind of things become very important, that you put systems which are compact, and copper will come to your rescue there very well, that everything is compact, the panel is compact, the transformer is compact, the bus duct is compact, and you release unnecessarily the real estate, which is very valuable to the owner. And then if you use copper, again, there is no need of bimetallic contact, because most of the breakers, MCCBs or MCBs or ACBs, they all come with copper contacts. And so when you connect to, aluminum bus bar, you need to use bimetallic contacts. No need. You just use the copper. Reduce chances of fire in the building due to lesser heating and terminals, which I had spoken to you earlier. Power factor is also a very important role in the overall scheme of safety and power quality in the power. And you would be, I don't know, I think I mentioned somewhere here, yes, that nowadays always maintain your near unity power factor. Lesser size of cables you would require if you use unity power factor, because for a lower power factor the cable size increases. Heating would be less, because heating is directly I square R, while you may be drawing the same amount of power, but your I would be higher and the heating would be higher. I came to know only a couple of weeks ago that almost all electricity boards in India now, distribution companies, have been now asked by various regulatory authorities to charge consumer on kVAh and not on kWh anymore. That means the basic unit, energy unit in the country, is now being redefined as kVAh, and therefore this power factor will play now bigger role. Earlier 0.95 ho gaya, chalo theek hai, nothing more is required to be done. Now electricity boards and companies and everybody has become smarter, and wherever there is a scope for charging, they are charging. So if you have consumed 100 units of kWh, but you have consumed 105 units of kVAh, now you will be charged for 105 and not 100. And therefore this power factor plays a very important role now, and we should all be careful and maintain a near unity. Standards governing harmonics are
Sorry,
there.
Mr. Jain. interrupting you.
Yeah,
Kindly be short now because you are overstepping the time. Please kindly finish as quickly as possible.
sir, this is my last slide.
Okay. Thank you. Thank you.
I was looking at the clock anyway. It's there on the presentation.
Very good.
So these are the standards which are there for harmonics. Those who are interested can go through these standards, and these are followed everywhere. India is developing a current harmonic standard now. This is where my presentation ends. I think we will have a separate session for questions later. I don't know, maybe now.
I think we will have it later. That would be better.
Yes.
Thank you very much, Mr. Jain. Thanks a
Thank
lot.
you. Thank you.
Mr. Jain made a very, very lucid and excellent presentation on the need for power quality in high-rise buildings. He has raised the subject of this quality design, execution, and maintenance of electrical systems in high-rise buildings, the importance of that. And he has also stated various mitigation measures that are available for meeting these power quality deficiencies like UPS, inverters, AVRs, harmonics filters. He has also dwelled upon the bad effects of harmonics. We have to give very huge importance to harmonics control now, looking at the major problems with harmonics generation. He raised about frequency fluctuations also, but I think after 2012 grid failure, we have taken numerous measures to control and make frequency fluctuations very, very low. Now the CERC mandated frequency range of 49.5 to 50.2 is quite stringent, and it is being further tightened in the light of new Indian electricity grid code, which is coming up shortly. So it will be further tightened. So on frequency front, I don't think we will have much problems. Gradually, we will not have any problems on voltage also, but yes, other problems will remain. I want to bring one more thing to the notice of the audience that Mr. Kundu will, I think, corroborate this. In our meeting, when we were doing discussions on power quality regulations, one of our members, Mr. R.N. Sen, who was then chairman of West Bengal Electricity Regulatory Commission, commissioned a small study. He got his people to purchase some LEDs from the market and see their power factor. And we were surprised, rather stunned to see that some LED lamps had power factor of the range of 0.1, 0.2. So, making regulations or specifications is one thing, implementing them is another thing. BIS can make standards, but how to implement them is another problem in our country where large scale illegal imports or local manufacturing is quite prevalent. So, that is, I think, an issue which needs to be deliberated also. We'll now have a second presentation. I thank Mr. Jain. Now we will have second presentation from Mr. Rajen Mehta, who is CEO of FEG Energy Consulting Private Limited. He holds a BE degree as well as a master's in IE from Missouri, Columbia, US. He has over 20 years of experience at various levels and is currently CEO at FEG Energy Consulting Private Limited. His expertise spans designing, manufacturing, deploying, and commissioning advanced power conditioning solutions and conducting advanced power system studies. He is also proficient in developing software and hardware-based product platforms for solving complex concerns in the power quality and electromagnetic environment, which affects reliability, safety, and efficiency of power system of facilities. Mr. Mehta, you please have 20 minutes. Kindly remain within these 20 minutes. Kindly start your presentation. Thank you very much. Over to you.
Thank you so much, Bakshi sir. Just a minute, I will just. So thank you, sir, with a lot of humility and for invitation to speak on behalf of stellar institutions like CEA, BIS, International Copper, and EMA. And of course, a delight to be present along with one of the few persons in my professional life whom I revere and respect very much. Sometimes fear him too, Mr. Jain, and yeah, Dr. Venkatesh. A pleasure to connect with you too. Thank you, Bakshi sir, for the introduction. So I'll try to keep the session short and allotted within the allotted time. So I would just like to say that I've had the good fortune in terms of my career, to have a kind of an all-rounded opinion, if I would say, from three different perspectives, if I would say. First and foremost, being able to witness the pain points that facilities of any kind, be it a commercial, high-rise, or even industries for that matter, experience firsthand in the safety, reliability, power quality space. Then diving deeper to solve these problems by providing solutions. That's my second role, which I played. And lastly, in my latest role, being able to detach ourselves from the solutions and focus on how best to avoid the problems in the first place. That's been my endeavor, my company's endeavor, and provide in this short session, I try to provide some secret sauces based on the experiences of the last 20 years. And this experience, I would say, lastly, following my perspectives in these three areas, I also have tried to dabble, contribute into standards building, which I am really fortunate that I got exposed to following the footsteps of Manasa, and had helped me to be part of various standard formation committees in power quality. And while Bakshi sir, and Jain sir were just mentioning, it's so coincident that NEC, that's the SP30, has just right now I got this email of reviewing the section 20, which includes the guidelines on power quality improvement and power factor and harmonic correction, as well as conductor deratings and quite some interesting areas that has come up. And this shows that we are definitely having power quality on the radar. It's part of the everybody's rhetoric nowadays, and serious action on the part of BIS, on the part of CEA, which is happening, CRC, etc., is going to play a stellar role in helping us move to the next level. So I'll dive into the centerpiece of attraction, if I would say, of our story: commercial buildings and high rises. Okay, the graphs which we see over here, they kind of tell a telling story. Okay, a tale of two maximum cities, if I would say, New York and Mumbai. Obviously, the first observation which I had on seeing this graph was the rapid modernization and developing country growth rate that you can see with respect to the number of high rises that are growing. Remember, this is just Mumbai. And at the same time, New York shows a steady timeline, steady state growth. This timeline is from 1970 to 2020 approximately, whereas in Mumbai we see almost nothing pre-2000, and slowly the growth in high-rise buildings has started. The high-rise building is defined as a 30-story plus building in this case. So it's not a big proportion of all the commercial buildings that we are speaking about, but still it gives some perspective to our story. Whereas New York has a pretty steady growth in terms of the number of high-rises in the last 50 years almost. But now this graph juxtaposed with the next slide, it kind of paints a very stark picture, and in my opinion makes it much more scarier. Okay, uh, every 2 days in Mumbai we have had fires for the last 10 years. That's the statistic that comes out, with approximately 1568 incidents of fire reported in high-rise buildings for the last 10 years. That's something that juxtaposed with the earlier slide, where the average age of our buildings is only 9 years. If you have seen that slide earlier, the average age is only 9 years, whereas that in US is almost 37 years. Makes me wonder, makes me worry that it obviously is throws open a lot of questions. A lot of judgments can be made, that whether is it the rapid rise of this urbanization, is it at the cost of safety? Is it that we as a country are ill equipped to handle such a high quality growth with quality infrastructure, or do we consider even cost of human lives that might succumb to such fire incidents while we are making decisions on unseemingly deadlines on project completions? Okay, that's my experience that I've been experiencing for the last 20 years. And the graph, on the right side paints that picture so accurately, where the survey by Ficky shows that apart from fire and natural calamities, no other external macroeconomic or macro business factors, if I would call them, have grown in terms of the risk. Fire has jumped from a rank of 9 to a rank of 3 in terms of risk to business operations in just 3 years. That really tells a very, very strong tale in terms of how we are managing, how we are designing, how we are installing, how we are maintaining our electrical installations. So, while we talk about what kind of world we are leaving our future generations to inhabit from the climate change perspective, equally within our buildings and within our homes, are we leaving them a safer place to live while the outside world is at threat for natural calamities and global warming? The mirage of being safer within our homes and places to work will also be called out sooner than later, is what I believe very strongly. And we, the fraternity in the electrical installation, in the electrical designers, consultants, contractors, we really hold a moral responsibility to do much more in India for these buildings to be made much more safer and reliable. Okay, so yes, this we spoke about what the statistics were telling us. I will try to bring out some facts, okay, of some things which common building managers or common commercial building owners, facility managers do experience. So something like, is the building owner aware of simple standards and codes which are responsible for ensuring the upkeep and safety of his building? Are we aware of the codes which are built so painstakingly by institutions like BIS and by CA, like IS 732, IS 3043 for earthing, NBC, NEC 2011, and what kind of actions have been taken to ensure that the building complies with all those regulations? I find that woefully inadequate in India with respect to doing these compliance studies on existing buildings that are being built, that have already been built, or even new buildings which are coming forward. So this, graph that you see over here. Okay, the second point which I wanted to highlight is the point about voltage quality. Is voltage quality something that is on our radar? Do we feel worried about it at times? Is voltage harmonics, is voltage fluctuations, like James also mentioned, is it something of a concern? So this graph which you see on the bottom right, it tells the story of this voltage quality and the voltage survey that we keep on doing across multiple facilities, and it tells us that voltage variation is experienced very highly in 44% of facilities, meaning it is crossing the bare minimum threshold or the bare minimum benchmark that standards are set for maintaining these voltage quality standards. So while I'm at it, the first standard for voltage quality in India, IS 17036, again I was fortunate to be a part of the standard forming committee, has been rolled out almost a year and a half earlier. And still, I would say I feel really to a certain extent embarrassed to find out that utilities even today in the country, state utilities, are not aware of the standard which they are themselves supposed to comply to. It's a standard which has been borrowed from EN 50160. No qualms about that. But at the same time, while we have taken the efforts to roll out the standard for our country, for our utility companies, for our distribution companies, what steps are we as a aware consumer, as an aware building owner, taking to ensure and find out whether we are complying to this voltage quality standard, voltage quality or not? And then go back and talk to the utility with a meaningful discussion with some data on the table to show them that, hey, look, this is the kind of voltage quality that you're giving me. This is causing me XYZ kind of impacts in terms of losses, in terms of downtime, in terms of sags, transients, etc., etc. So that is something which is something that I would encourage building owners to take cognizance of. There are standards available now. Go out there; they are available for free on BI's websites. A lot of the old ones, the new ones are at a very nominal price. Go and buy them. It will give you a lot of insights on what needs to be done to protect your facilities from these different hazards of power quality, safety, reliability, etc. We will speak on that in a little while. Going further, electrical safety, okay, has been again the topic of today's session. So is that a risk again? So in that context also, my experience again is that thanks to efforts by quite a few early adopters, okay, Jain sir being one of them, whom you have over here, the concept of third party testing and verification is really catching on. And this, expectedly, it reveals phenomenal gaps which are missed during the installation phase by the last mile contractors and their workforce, which are driven more by experience, rather than professional learning or skilling. So as you can see in this graph, for example, we have been doing so many tests on hundreds and hundreds of different kinds of equipment, like breakers, like RCDs, like transformers, conductors, and you find that a starting high number of failures, or rather not failures, failures in terms of the test parameters, which we find while we are doing this testing. Almost 92% of the facilities that we are doing, they have a missed coordination between the breakers, from the all the way from the high voltage all the way to the low voltage. RCDs, almost 33% of them failed the simple test of conforming to an OEM's time current coordination curve. So that, which means that in the event of a crucial fault that will occur in the system, the last mile protection that you have in terms of your RCD is not going to act. It is not going to protect your installation. So how vulnerable, more vulnerable can we be? Going further, all of building facilities which I have come across, they have one time or the other faced inexplicable downtimes in their facilities. And we have been privy to a host, many of them. I will take some of them in my case studies further on. And have you faced any malfunctions of sensitive equipments in your facilities? Is harmonics something of a concern? Jain sir explained very lucidly, very beautifully earlier. But is it something of a concern? Have you heard of supra harmonics? We are now transcending from harmonics to supra harmonics, and we as a country are still yet to have a handle on the basics about harmonics and how to mitigate them. But as I said, with the standards coming in, with utilities migrating to more awareness, I am very confident that we will reach there sooner than later. So the question that I would like to ask ourselves is, how much do we want our buildings to last? And is it 25 years, 50, 100 years? I don't know. Some of you must have heard of the Empire State Building, which it just comes to my mind. I had read an article about it some 2-3 years ago, which has been in existence for almost a whopping 85 years. Okay, and even today, it continues to challenge the existing benchmarks on energy efficiency. It continues to challenge the existing benchmarks on retrofits and upgrades that it does to the communication systems, to the building wiring, to the bus duct risers, which you see that they have been retrofitting, aiming to make it more safer while following each and every compliance by having regular training sessions with all the contractor, foremen, technicians, etc. And top it all without a single minute of downtime. That's the story that we need to really see for ourselves, that if an Empire State building, a building of 85 years can do it, what stops us from doing it when our buildings are so young in age? And will we be able to do it looking only not only at efficiency, but at all these 4 aspects of safety, reliability, compliance, and quality for our buildings? So that's where I want to tell that the need to focus on power quality more along with efficiency is something which is an imperative argument today, and not just something that is a good to have. While building management systems are becoming more intelligent today, but still the shift to power quality is not so fast. Okay, and in the absence of implementable regulations and standards, it is obviously a hard task to achieve. So on the standards and regulations, we have an unparalleled authority in Bakshi sir, so I will not dwell on those, but I am pertinent to mention now that I will avoid getting into the jargon of what is power quality and its substituents. But I would like to focus on the operational and functional implementation aspects of power quality, inside buildings, and what benefits it can bring, and why it should be part of your a building owners or a building manager's arsenal in their targets to achieve higher safety and reliability. So, for example, let's take the first thing: early detection of problems improves reliability. Think about preventing nuisance tripping. Think about preventing failures in LED lights, which we commonly get from 1 in 6 to 7 client complaints. What she said mentioned about the study about LED lights, and very revealing study where not only power factor was found to be low, even in some of the cases, two or three of them out of those 10, I think, makes which they studied, harmonics was found to be very high. In almost 3 to 4 of them, they did not have any BI standard compliances. So, this is something which can be detected earlier with proactive monitoring of power quality. If you're talking about tracking PQ issues leading to longer equipment life and lesser downtime, this kind of benefit can come when you think monitoring for harmonics and taking corrective actions much prior. So, for example, they can enhance the life of your capacitors, they can enhance the life of your conductors, lesser heating of the loads, and hence longer lifetimes. Third, monitoring power quality parameters helps to arrest wasteful capacity expenditure. This is something which I've experienced so often. I can give you a live case, which I was just discussing prior to this webinar, where there's a case of a UPS which is not able to take a load more than 60 to 70% of certain air handling units. And the solution that the facility owners or the managers are contemplating taking is just doubling the capacity of the UPS. Okay. Is that the right approach to solving the problem, or is it something to do with power quality that you need to really investigate and find out where does the root cause lie? And we are in the midst of doing the live monitoring, and we realize it's nothing to do with the capacity. It's simply to do with harmonics. It is simply to do with the design of the way in which the system of the UPS has been designed. So arresting your capacity expenditures is important, and power quality monitoring proactive can help you achieve that. And lastly, realizing untapped savings in energy bills. Again, not going too deep, but KVH billing is a reality. Maharashtra has shifted from April 2020. We have been having hordes of consumers facing enormous shifts, higher increases in their bills, not knowing that they are now having the invisible impact of harmonics, power factor, all of them combined, hitting their bill, while they feel that penalty or incentive of power factor has been taken away from them. They now need to be much more vigilant, and focus on power quality monitoring, power quality analysis, to find out how they can minimize the bills that they're getting today. So to integrate power quality in the life cycle of a facility, there are different facets. Okay, it can start from the greenfield to the operational to the retrofit stage of a facility, and there are various things in the power quality ecosystem, if I would say, that you can take up, to enable you to have a much better design system. For example, through power system modeling, you can accurately model the impact of transformer inrush to harmonic analysis so as to avoid surprises at the later stage. More importantly, it can help in studying the fault levels and designing the coordination of the entire system so as to act as desired in various fail-safe situations and fail-safe as well as normal operating scenarios. At the same time, the luxury to have a network quality monitoring when you do not have a critical load running cannot be overstated. Especially incoming voltage quality. Remember the IS 17036 I spoke about, and the quality of the installation at length without a downtime will never be available once the facility is operational. So I'm not going to delve into each of these different aspects of power quality that can help you at different stages of your life cycle. But I want to quickly take you through 3 or 4 live examples which can throw much more faster light. So the first one was a case of a building where there was a random tripping of a 4,000 ampere mains happening due to a ground fault. Okay, and what was done was a remote monitoring was done using a power quality analyzer, and you see the graph on the left. What you see over here was done where we monitored simultaneously 8 channels. Okay, so excuse me, the graph may not be fully visible, but what you see over here is this is the voltages. This is the line to line voltage, this is the line to neutral voltage, and this is the neutral to earth voltage that we are monitoring. This is the frequency. And then we devoted all the remaining channels to current. The first 3 channels were of the main breaker, which was facing the tripping, and the next 5 channels were devoted for monitoring the leakage current or the zero sum current of different downstream feeders, which were installed in the facility. It took us 4 weeks to find out, and it captured a sudden rise in the zero sum current at one of the feeder breakers, and which allowed us to identify that there was a ground fault at that breaker, and it avoided a costly breaker replacement because the facility was contemplating replacing the breaker rather than knowing what was the cause of the tripping of the breaker due to ground fault. So needless to say, that's a huge savings that the customer got, almost around 900%, because a lot of times I get questions on how do you show power quality is giving you a return. This is what a return it can give you. The next is an interesting case study we did for a five-star hotel, which was a power quality audit we did, and it was spread over a multi-location, multi-week monitoring. What this facility was facing was random failures or freezing of the elevators over a period of almost 4 years. They lived with the problem for 4 years because the manufacturer, the elevator manufacturer, was happily having a comprehensive AMC, and he was happily replacing the parts whenever they used to fail. But when we came in and we did a monitoring for almost 2 months at the stretch, you could see this graph is a summary of what we did for those two months, and it tells the story of those 2 months. It illustrates that you have to be patient when monitoring. It illustrates that you need a calm mindset and a free hand in terms of placing the monitoring system in a facility. And the more you have, the faster will be your returns. The simple conclusion from this is that the number of events that were occurring of elevator failures had a very high correlation with power quality events that were occurring across the facility, and this is normalized over a 24-hour duration. And the simple output of this was voltage sags were the cause of these elevator failures. A simple transformer tap change reduced 80% of these failures from there on. It was a free replacement, a free solution. They had to do nothing for it, but that's something they lived for 4 years, and that's criminal in my opinion. One more is a case of a very leading, won't name the brand, but it's a corporate headquarters of a high-rise building where we could spot a short circuit remotely by doing this monitoring. You see over here the neutral to ground voltage going to almost 230 volts in a matter of few 2 to 3 weeks that we did the monitoring. Again, it was a detection of an insulation failure between the phase to ground, which we were able to detect and help the facility take corrective action much faster. So these are some of the cases of remote monitoring, power quality monitoring helping you. And what you see over here is a typical architecture, of an overview of a typical architecture even involving remote monitoring for power quality, safety, and reliability all combined together. So, for example, energy, we were talking about kVH billing. It's all the more important that in today's world with distributed energy resources like solar, PV, and all being installed in a facility, you have a handle on how is your energy export and import happening. Because the solar PV inverter is very selfish by its nature. It's not going to give you the reactive power that your load needs. Your load is going to be requiring to pull that from the grid. So what is your export import of kVRH energy? How is it? Can you do that? So what about temperature humidity impact on your asset life? What about battery parameters in the case of UPSs, in the case of solar systems? If you monitor these battery parameters like impedances, DC current, voltages accurately, you can prevent the risk of fire much sooner. What about monitoring your load? High industrial and loads, will they at the grid edge, will they affect your solar PV systems which are connected with your utility systems? What about supra harmonics, which I mentioned earlier? That is higher harmonics from 2 kilowatts and above, which are going to become more and more the norm as more and more higher frequency inverters come into play in your system. So this, as you see, is a very typical architecture that can be deployed with the single analyzer, which is monitoring not only battery parameters, not only your solar PV systems, not only your backed up loads, not only your normal feeding loads. It is monitoring much more than that. And all of this can be remotely now monitored at the click of a button and allow to give you not only just the monitoring data, but more importantly, how it can remove all the guesswork and painful analysis to bring out easy to understand reports which are actionable in nature. So I'll just take my liberty to show a 1.5 minute video and end my presentation. I'm already at 24 minutes, sir. So the last one, I'll just show you this video, which is it will show you how this is possible in reality to do remote monitoring while getting the benefits of okay, sorry, okay. This is like a live feed of power quality monitoring, which you can see in the video. It has almost more than 500 parameters that is being monitored. These are the trends that you can extract out of it continuously on a live basis. These are some of the events, a voltage sag event, which you can see again live, how it is affecting your facility. Then this is a real-time dashboard of your real-time parameter gauges, if you will, voltages, currents, whatever you want to monitor with live waveforms. And this is all live. Okay, this can be monitored live sitting at your desktop. What about harmonic scans, voltage and current frequency scans? How are they performing? How are they affecting your equipment? Now this is all very high end maybe for a layman. So we have done is, you can see, is you have email based automatic status events and updates to focus on the most important ones. And more importantly, lastly, what you want is getting real time reports and compliances. You want to know directly, whether I'm in compliance to a standard or not, whether what I need to do, what is the action I need to do, what kind of savings I'm going to get from doing these compliances. So you see over here, there is a compliance of all different standards which are already being provided. You know whether the event of voltage sag is coming from upstream or downstream, whether the risk to my facility is red or is green, whether the savings, how much it will be based on different parameters that I'm monitoring, what is the asset performance that I'm having, whether it is to be replaced or not. If it is to be replaced, how it has to be redesigned, how it has to be retrofitted. So that's what is something that I wanted to just demonstrate very quickly on how a remote power quality monitoring system can help in multiple ways to help curb your reliability, safety, compliance, and quality issues, while at the same time ensuring efficiency of the system. So thank you so much. I've been very hasty in terms of my presentation. I think I'm aware, but with the paucity of time, I try to do what best. Over to you, Bakshi sir. Thank you so much.
Thank you, Mr. Mehta. You made a very, very bright, very lively presentation of the problems in high-rise buildings and their mitigation. I'm really very happy to note a few things which even I didn't know about power quality monitoring in high-rise buildings. In 2016, when uh, we started a campaign to measure power quality parameters in distribution companies. We did not come across a single company which could provide a single instrument to record and analyze all the power quality parameters. Then we came across a Swedish company called Solvina, who agreed to install some power quality monitors at different voltage levels in Tata Power Delhi distribution, and the results were quite revealing. On the basis of that, we took our power quality regulations work further. But I am very glad to know that now very usefully power quality monitoring systems are available, which can record, which can analyze, which can measure compliances, which can calculate savings in one go. And that's really very nice. And this should be, I think, used by all the high rise, not only high rise buildings, by other users, major users also. So we are very really thankful to you for an excellent presentation. Now I invite Dr. Venkatesh, Vice President TDK Electronics, to make his presentation, which is last in the day. Dr. Venkatesh holds a BE in Electrical and Electronics from REC Trichy, Master in High Voltage Engineering from Anna University, and doctoral degree from Indian Institute of Science, Bangalore. He has more than 30 years of experience in R&D and business management. He has 15 patents to his name. Thank you. That's excellent. 11 design registrations and more than 50 papers to his credit. And he has delivered over 100 invited lectures in India and abroad. He was one of the invited speakers at the Innovation for Cool Earth Forum. His expertise areas include R&D of power products, high voltage engineering, power quality, diagnostic testing and condition monitoring, product life cycle analysis, good large cycle integration of RE into power grid, CDM, sustainable development, I don't know whether CDM is still applicable or not. Kindly let us know. And low carbon economy, energy conservation, energy efficiency. I request Dr. Venkatesh, besides power quality, if you can touch upon CDM and energy conservation in high-rise buildings also, it would be very great. Yeah, thank you. Over to you.
Thank you, Mr. Bakshi. Good afternoon, gentlemen.
Good
Maybe Mr. Mehta finished his presentation with a video. Maybe I'll start with a video. Is my screen visible?
Yeah,
Okay.
absolutely.
Okay. So what you saw was actually a fire in one of the high-rise buildings in Dubai. This was just opposite Burj Khalifa, one of the world's tallest towers. And I was there that day actually. You know, it was on Christmas Eve, so I was there with my friends. We actually went out for a beer, and then we heard that there's something is burning. We just drove in, and this was caused by an electrical short circuit. You know, that is not to start with a dramatic event, but this is how critical things are. What I will do is I'll focus on power quality and electrical safety in two specific kinds of buildings. One is the hospitals, other one is the high-rise buildings. So what are the basic contents? I will say some basic things about electrical safety and power quality, and why high-rise buildings and hospitals are very special, and certain aspects related to power quality solutions for hospitals, certain issues for buildings, and maybe a short summary. Now, we talk about electrical power safety and power quality. There are a lot of power quality parameters. I've listed few of them, and these things affect actually the safety. You know, we know power quality affects a lot of stuff. We talk about kVH billing, we talk about energy, we talk about power factor incentives and penalty, we talk about energy conservation. All this is known, but these parameters like harmonics, unbalance, electromagnetic interference, interruptions, neutral shift, and reactive power and surges, apart from the damage to equipment and electricity bill, can actually affect safety. You know, if time permits, I'll take you through how accidents have happened because of these power quality issues. And some of the impacts are additional heating. Of course, whenever you have harmonics because of increased current as well as skin and proximity effect, you have additional losses, which means overheating of insulation like plastic paper insulation, leading to fire hazards, lower reliability. There are equipment failures, and one of the key things because of poor power quality is the equipment malfunction. You know, I personally did a case study in one of the world's largest hospital. You know, I was just counting when Mr. Manas spoke to me. I counted the number of hospital power quality installations I've done, and as of last year I completed 67. You know, that was a great learning for me. And in one hospital they have to improve power quality not because they have a kVH billing or they get a penalty or a tariff benefit, because the equipment, sensitive healthcare equipments, were tripping because of harmonics. Okay, you're talking about a human life. Let's say you're in CCU, the monitoring equipment does not work, it malfunctions because of power quality, then a lot more is at stake rather than, I would say, you know, energy bill. And of course, a compromised electrical safety. Let's look at very broad stuff. What happens to equipment because of these power quality parameters? You know, some of these like harmonics, unbalance, interruptions, neutral shift. What happens is you have equipment damage, you have fire, sometimes even explosion, and definitely equipment failure. Failure could be not a normal failure, but worst case scenarios, you have an abnormal failure mode, you know, which is called as a reliability. So whenever you have a power quality problem, you have a faster aging because of heating. We know there's an 8-degree or a 10-degree rule. All the insulation, they age much faster. So what a transformer is designed for, let's say 40 years, can live only for 20 years. Mr. Mehta was talking about high-rise buildings living for 80, 90, 100 years. Maybe he's talking about the concrete structure, which could live for 100 years. But what about the transformers and the cables which are inside the building? Are they designed and are they maintained to live for 100 years, or they still have a life of 20 years? It's not only the equipments fail, they have abnormal failure modes. I used to say equipments would fail. You know, when God made things, like God created me, I would fail. One day I would die. So when God made things will fail, man made things will definitely fail. It's not a question of failure. It's exactly like death. When will it fail and how will it fail and what will go along with it? So an equipment failing is not as bad as taking the whole building along with it. And the worst case is equipment malfunction. When something fails or it burns, at least you know it's damaged, you replace it. But when something is just malfunctioning once in a while, then it's very difficult to fix it. Apart from equipment, the power quality related electrical safety also affects humans, like accidents. There's a whole handbook talking about electrical safety for humans, especially related to power quality, health hazards, and safety concerns. If time permits, I'll go through a little bit into that. Now, why is that hospitals and high-rise buildings are very special? There are three electrical installations where electrical energy is very, very important. And to me, these installations are very, very special when it comes to power quality and electrical safety. So we'll talk about two of them. One is the high-rise building, definitely. And let's see why high-rise buildings have to have a very special treatment. The second ones are hospitals. The third one is marine. I was talking to Mr. Kundu when he talked to me about this seminar. And this is a public report available now. It is released by the Lloyd's registered insurance company. A ship has a huge propulsion system, 4 or 8 megawatt generator, transformers, cables, etc. RMS Queen Mary 2 caught fire with almost about 600 people on board near Spain. Fortunately, no one died because it was very close to the Spanish port and people could be rescued. And otherwise, it would have been another Titanic. And the engine room caught fire because of harmonics. And why do we think, okay, we will not talk about marine power quality today, but when you talk about power quality in high-rise buildings and hospitals, why do you think it's special? I believe so. It's because of the two reasons. One is the evacuation challenges. So whenever you talk about fire in a building or some kind of accident in a building, could be an earthquake, what is the first thing you do? You evacuate people. Now, evacuation itself is a challenge in a high-rise building and in hospital. Why? Look at the profile of the evacuees. What do you mean by the profile of the people to be evacuated? Let's say you're in a hospital, you're in an ICU, you're in a bed with a lot of pipes sticking to your, let's say, chest or lung or kidney, whatever. The fire alarm sounds, you're not going to run out, okay? You need somebody to carry you. So you're talking about patients, elderly people. So evacuation is a much bigger challenge compared to, let's say, an industry where every month, whether you like it or not, there is a mock drill. People assemble, there's an alarm, people know what to do in the event of a fire and electrical stuff. Second one is the access to the service providers. Even if you cannot run on your own, if somebody is going to walk in and carry you out, it's possible in an industry, but it's going to be very difficult in a high-rise building where you can't even access them. The service providers, be it the fire, the healthcare, or the police, they just can't access the 100th floor immediately. It's worst case in a marine accident, right? If you're in the middle of Atlantic or Pacific, it's very difficult to provide access to the service provider. So because of this evacuation challenge, the power quality and electrical safety becomes very, very important and very different from the electrical safety and power quality, I would say, in a normal commercial building or a residential building or an industry. The second requirement is hospitals and high-rise buildings, apart from the evacuation challenges, have a very special requirement when it comes to power quality. The quality and the reliability of power supply must be extremely high, especially in the case of a hospital, because you're talking about sensitive instrumentation, if which it malfunctions, you can have a person dying. That means we are talking about very, very sophisticated instruments with a very high level of EMC requirement. Second parameter is the high dependence of electrical power even for the routine activities. For example, you take a high-rise building, if there's no power for 30 minutes, even if there's no electrical fire, a patient, let's say a guy living on the 100th floor has a chest pain and he's getting a heart attack, you lose the golden hour. Without the lift, you just cannot run down the 100th stair. Okay, either you jump out and die of an injury or you die of heart attack. These are the only two options left. So in hospitals and high-rise buildings, again in marine, the dependence on electrical power, even for the routine activities, is very, very high. So if the electrical power is going to be compromised, even the normal routine activity comes to a standstill. You're doing an open heart surgery, the power fails, that's the end of story. The last is you need a backup power for emergency services. In most of the designs, you would find the backup power does not have any higher level of reliability, and the level of redundancy is not so high. So when the primary power is compromised, the backup power also goes along with it. And these parameters make it very, very relevant and important that power quality and electrical safety for these three, and the two we will talk about, high-rise buildings and hospitals, very different and very challenging. Now, this is a case of a hospital, just to prove my point. I could have taken everything from the net, but this is a hospital. Just read only the highlighted point. This is in 10 years in Korea, this is one of the worst hospital fires. What is most important is read the last line. Police said that 34 of the dead were women and 26 were aged older than 80 or more, So if you're talking about a hospital, generally people there are not valid, they are invalid. They need support even to walk. So when you have a fire, it's going to be very difficult to evacuate. This is just to prove of mind. You read this, like Mr. Mehta said, the high-rise buildings are coming up much bigger way in Mumbai, yes. But if you see Middle East and China, apparently they are in a race to build the world's tallest buildings. So you have Burj Khalifa, then you have something in Iran, then something in Saudi Arabia. And this is taken from newspaper clippings, In the last 5 years, Dubai had the highest number of high-rise fire accidents, and 9 out of 10 were traced to an electrical failure or a short circuit or a flashover, right? The one what you would see next is the address downtown. We had just 1 year after that in a hotel in Jumeirah. The last clipping is from it's from an author. He writes a lot on this building code. He talks about in any building, which is more than 75 feet height, measured from the lowest level of fire department on the highest occupiable story, should have a totally different, I would say, regulation for electrical system. This is all known. Every country has a building code. The question is how much the spirit and word of this building code is really practiced so that we can avoid these kind of fires and accidents. So this is you saw the video clip, so I will not take you through this. Since I saw it in person, I was really impacted. So when Manas Kundu said, can you speak? I said, Manas, I was there when Burj Khalifa ka samne jo tha na tower, it was burning. And this is what it is, and it is a 63 story. The key thing is the alarms did not sound. Why did the alarms did not sound? The electrical fire was outside the building. The smoke was outside the building, and the alarm was made inside the building in the corridors and in the rooms. So until almost everything was burnt, even the fire safety system did not work. Here again, the key is it's just 15 people injured. I mean, I won't say just 15 compared to the previous 37 in Korea. And one person suffered a heart attack when he was being removed from the building. So this is the kind of complexity you handle when you talk about evacuating high-rise buildings. This is again a very famous one which happened a couple of years back. It's a 24-story tower in London. It's a complete apartment where people live. In an industry, you have engineers, you have trained people, etc., etc. I'm talking about a middle-class apartment where people, I would say, middle-income group. I mean, in certain countries, even the middle-income group lives in tall towers. If this kind of things happen, it's going to be very difficult. A housewife or a school-going children living there may not be well versed in evacuation procedures. And here, read this line: the mantra of high-rise protection is compartmentalization, suppression, and evacuation. So if these three are compromised in any building, in any device or any equipment which is installed in a building, you are in for something big trouble. Now let's look at the hospitals. We look at two specific cases of hospitals and high rises. So you look at all the hospital loads I have today. You have HVAC. HVAC systems today have harmonics because most of the air conditioners are inverter driven. You no longer have the induction motor. That means they also have a VAR requirement or a low power factor. You have lighting. 100% of lighting is LED. This is single phase, and any single phase means it's an unbalance. You could have large neutral currents and all the three phases will not be balanced. And today's lighting, unfortunately, is no longer the Edison's incandescent bulb. Either you have CFLs or you have LED SMPS driver, which means the power factor could be as low as 0.4 and as much as 70% THD. Then you have UPS. Of course, hospital need UPS. You will not start an open heart surgery without a backup supply. But UPS do generate harmonics. Of course, today you have 18 pulse drives and 18 pulse inverter, 3-level topology with active front end. They reduce less harmonics, but they do generate harmonics. Of course, hospitals have a lot of servers, computers. Most important thing is the lift and escalator. Let's say you have a lift, like in the tall building. If the lift is compromised because of electrical power, even the evacuation is compromised. Then you have all these medical equipment, MRIs, CT scanners, ventilators. Each one of them has a switched mode power supply. The input for all these equipments no longer uses a linear power supply. Since it's an SMPS, you have a lot of harmonics, also EMI, EMC problems. It's like supra harmonics 2-3 kilowatt. I'm talking about much higher frequencies. People are already talking about drives not using IGBTs but with silicon carbide devices, switching at 50 to 100 kilohertz. So the entire concept of harmonics, the so-called third, fifth, 11th, in very near future would be, I would say, irrelevant. We are talking about much higher frequencies. Firefighting systems, access control, security control, utilities like water pumps, motors, etc. And most important is the diagnostics and life support system. And all of them are again single phase. They create unbalance. They have switched mode power supplies, and they are very susceptible to EMI, EMC, and most of them have a very low power factor. These are the typical loads what you have in a hospital. Now, as I said, most of them are single phase loads. That means they have an unbalance. They create sequence components flowing all over the system. And then you create a neutral voltage shift. That means some of the equipments which are connected to line to neutral and requires a zero voltage on the neutral can even start malfunctioning. I won't get into the details. If somebody is interested, I can give you examples. The second one is most of them have a high harmonic distortion because all of them have switched mode power supplies. That means there's excessive heating, more currents, RMS currents go up. When the currents go up, you have excess power loss, not only because of higher RMS currents, but also because of skin and proximity effect. Then we have the low power factor issues, and most of the equipments in hospitals are sensitive electronic instrumentation, and they require near perfect sinusoidal excitation. So if the input power supply is corrupted, either because of the grid power supply not being good or because of you injecting harmonics through a source impedance, whatever be the reason, some of these equipment starts malfunctioning. There was a case, let me complete the next one. The other one is most of these equipments are very sensitive, and they should be having a high EMI, EMC compliance, but notwithstanding, if you're going to create more high frequency noise surrounding these instruments, then they tend to malfunction. And some of these instruments are tied to patients, and they monitor the patients, or even they keep the patients alive. So if such equipment starts malfunctioning, I mean, it's a sure shot death, right? And one of the cases, where I learned this was one of the largest clinics I've seen in my life. It's almost like a 7-star hotel. It's in Middle East, and they have it's a 7-story large hospital. And then they had installed some active filters because they had harmonics. But after the active filters were installed, they had a lot of equipments malfunctioning, because of the EMI, EMC coming out of the active filter itself, because of the PWM switching frequencies, So even the selection of the power conditioning device is also very important. It's not that you have a power quality problem, you buy an active filter or a passive filter. No, it's not going to help. In fact, it can make your problem much worse. So these are some of the hospital issues and the solutions. I won't get into that. It's been already discussed with a couple of speakers. So if you have harmonics, there are a lot of solutions. You can have detuned PFC systems, passive tuned filters, active filters, series filters, and shunt filters. Unbalanced, again, you have a lot of solutions. Neutral shift, you have solutions. EMI, EMC, you have solutions. But the key stuff is not that you should know your problem. It's not that the solutions are not available. The key is what I've highlighted, the last but one line. Choose the appropriate and the optimal power conditioning solution with the right specifications. And this is where most of them, they go wrong. Because as I said, hospital power quality and safety is a slightly different ball game. Most people who buy the power conditioning device, I mean, the intentions are good. They understand the power quality problem. They want to solve it. They buy an equipment, could be a transformer, or they specify a cable, or they specify a filter, but this is not the most appropriate one, because there's a whole lot of solution available, and every manufacturer is trying to sell what they think they have. At the end of the day, the customer or even the consultant to a large extent are confused, and they end up buying the wrong product, which may not solve the problem, and worst case can actually increase the problem. And this is one thing I showed to all the hospital. As I said, this is my 67th hospital. I said, you look at the patient ECG, there's okay or not okay. Similarly, there's a plant ECG, which is called as electrical characteristics graph. And like you have an ECG, what is defined in terms of time period, even for a pure sine wave, there's a definition. And unless we meet it, you're going to compromise something in the hospital, be it an equipment malfunctioning or a patient safety or operator safety. And this is a high-rise building again. These are the kinds of loads what you have in a high-rise building. You have HVAC lighting. Here the lighting is very, very different. And these are very powerful lighting. I mean, if you have seen the Burj Khalifa, they keep changing their lights. For example, you can see it during Diwali time, though it's an Islamic country. Or you must have seen even during the Independence Day of India, the Burj Khalifa facade looks like an Indian flag, And there's a huge amount of lighting. And you might think it's all small LEDs, The total lighting runs into megawatt in some of these buildings, It's not even watts and kilowatts. And all these lighting is unfortunately, again, nonlinear. They create a lot of harmonics, as much as sometimes even 70% THD. And since lighting by definition, and most of the lighting is not most, I think 99% of the lighting is single phase. That means they create a lot of unbalance and sequence components. High-rise buildings do have UPS. Most important things are the elevators, elevators, lifts, and escalators. And if you have traveled Burj Khalifa, or the one I did, my power quality study, the first one was in Shanghai Tower, That was the world's tallest building few years back, Shanghai Tower, where we did a complete power quality study and solution. There are lifts which go up from ground floor to the 50th floor, and the acceleration is almost like a maglev. They really have high speed escalators. So what happens is the current is 0 ampere when the lift is standstill. When the lift picks up, the current goes from 0 to as much as 1600 ampere in less than a second. And if the lift is fully loaded, some of the lifts can even accommodate 24 people. When there's a full load on the lift and it's going to accelerate, you see suddenly the transformer actually humming. The transformer hum goes up because the load on the transformer goes from, let's say, 20% load to 120% load, right? Then we have firefighting system, which are again with a lot of SMPS, access control, utilities, appliances. The key stuff, like I said, in the case of hospital, there is a key stuff related to EMI, EMC. In high-rise building, one of the main differences is the long cables. So now when you have a long cable running from the ground floor to the 75th floor or the 100th floor, there are additional losses, additional voltage drop. So when you have a voltage drop, and the voltage drop is quite significant, the voltage you apply to the device is much lower. And depending on whether this is a constant impedance load or a constant power load, it can draw a higher current. For example, if there's an induction motor on the 75th floor, if you apply a lower voltage, for the same torque it has to deliver, it's going to draw a current which is much higher, which is going to create the voltage drop more. And it may not even start, the motor gets heated up, etc., etc. And when you have long cables, you also have effect of skin and proximity. And the worst case, like in some buildings, they run all the cables together. That means the power cables, the data cables, the signals cables, everything, which is again inviting disaster. So these are some of the specific solutions, like the selection and application of appropriate power conditioning equipment protective devices. And some of these protective devices are very simple, low-cost devices like RCDs, ELCBs, MCCBs, even right rating of the fuses. And fuses are something we never select properly. And some of the fuses, because of fear of nuisance tripping, you might as well put a copper bus bar there. The building fire will melt it down, but not an overcurrent. These are very small stuff, a few dollar fuse, but then if it's not wrongly, if it's not correctly selected, can be a major disaster. Then we should have the right design of rising mains or cable ducts. Most important is the segregation of cables, data and power, and segregated bus ducts. So even in the case of a flashover, it's compartmentalized. The most important thing is the good ventilation for cable ducts and good ventilation for power equipment. Like what Mr. Jain said, I have opened some of these cable ducts. You can see the heat. You can feel the heat hitting your face. It's so hot inside. Then some buildings today have an internal high voltage distribution system where they don't take a 440 volt or a 690 volt cable up to the top. Actually, you run a 11 kV cable, which means the currents are much lower. There are no power loss. On every, let's say, 20th floor or a 40th floor, they have a transformer. They step it down and then they redistribute the power, which is a good design. Then I definitely would recommend use of copper cables and 4-core cables. Copper cable, not because the seminar is funded by copper promotion, but then they have much lower losses. They have a much better skin and proximity performance when it comes to harmonics. And in my opinion, in some cases, I've even used 5-core cable, where the neutral is the 2-run, because the neutral carries more current than the phase. And one can prove with certain kinds of loads, harmonic loads, the neutral current can be much more in terms of magnitude. And also the neutral currents will be having 150 hertz, the third harmonic, which means you need to provide for the proximity and skin effect. Other one is the sizing of the power equipment, not just the normal sizing, because all the electrical power equipment, the transformer, the motor, the switchgear, even the energy meters are designed 100 years back, the basic design, which assume two things, that I'll have a sinusoidal excitation and it will be a balanced 3-phase. Today, neither the excitation is sinusoidal, nor it's a balanced 3-phase. So all the sizing of power equipment, including the design, should consider a very high level of unbalanced sequence components and non-sinusoidal excitation. Then one very important stuff is compartmentalization and firewalls. This is not only at the building level, but even at the component level. If you're coming from a switchgear industry, whether you do a low voltage or a medium voltage switchgear, people today insist on certain forms. You have form 2B, 4B, compartmentalization and internal arc-proof panels. Today, I believe it's mandatory that we specify the panels with a very clear compartmentalization and depending on the requirement, internal arc-proof and the kind of construction. Definitely 100% redundancy. Why redundancy here? Let's say you're on the 75th floor, the mains burns out, the lift don't operate, then you cannot anyway evacuate. So hospitals and high-rise buildings, the electrical system, there must be a system and a B system. And the B system must be totally independent from the A electrical system. There must be a primary electrical and a secondary electrical system, and they must be totally isolated galvanically and physically, so that the failure of one electrical system does not affect the performance of the second electrical system, which may not have the full power, but this can provide the emergency services. But the most important, in my opinion, is not just specifying the right product or buying the right product. It's a good O&M practices. A lot of fires have happened not because the equipment was bad, but it's been very poorly maintained. I don't want to get into the detail, including the London fire is not because it was a bad equipment. The maintenance was very shoddy. So maybe people should not look at breakdown maintenance, not even preventive maintenance. Maybe we should look at predictive maintenance to reliability centered maintenance. This in a large way, though it's not really power quality, it's about asset management. Now, this is a summary of some of the application requirements. For high-rise buildings and hospitals, you need a much higher level of safety. Now, if you ask me, don't you need safety in industry? Yes, you need safety in industries. But industry, in the event of a failure, there are trained people, there are firefighting equipment. The damage could be controlled. But in a high-rise building where people live, housewives and kids are in a hospital, you cannot assume that there will be an evacuation drill and people will be evacuated. You need to ensure that, first of all, there's no fire, and not plan for how to evacuate when there's a fire. So when you're talking about high safety, everything right from cables to switch gear to power conditioning equipment especially should be a type tester design. And there must be a separate E neutral, protective earth under neutral. Especially in India, even a good electrician would not know the difference between a neutral and an earth. We think the protective earth is the fourth wire, which is also the neutral, which is the cause of half the problems. Then in most of the cases, if you read the Abu Dhabi ADDC standards, even for a simple APFC panel, they now specify, not now, 5 years back, they started specifying the equipment should have an integrated smoke and fire alarm, so that the PQ device, when it catches fire, it doesn't take the building along with it. Then the quality of components, wires, the most important is the thermal design and the touch potential. I mean, because of the lack of time, I didn't get into how with neutral shift, people can even touch the surface of a panel or a so-called dead design, but can get electrocuted because of neutral currents and because of leakage currents. And leakage current is one of the biggest killer if the leakage current design is not properly taken care. And a very robust first level protection. That means you have a fire alarm, you have a firefighting system, but the electrical equipment, be it the Buchol's relay or be it the overcurrent relay or be it the earth fault relay, they are the first line of defense and they should have a very high level of reliability. The second aspect, apart from safety, is the reliability, which is a long-term quality. You should again have a modular design. It should have a very high level of EMC compliance. As I said, in a hospital, we supplied active filters not because they have KVH billing or they have a problem with neutral burning or whatever. They had malfunction of what you call as a patient care equipment, and they really don't know whether the patient is dying or because of it's an electromagnetic compatibility issue. And then proper sizing, selection specifications. Other one is a very high level of availability. That means you need to go for modular designs. I'll maybe show you some examples of what these modular designs are. An independent module operation, so that when one module fails, the rest of the equipment still operates and gives you the power, so that you can at least start your emergency shutdown measures. Very low downtime and MTTR, because it's a critical installation. Again, you should have a modular design, interchangeability of modules, etc. Ease of maintenance, again modular on the type of construction. And this is something very key, about hospitals. You talk about all electrical equipment, and in this particular case, we found out that the patients were complaining about the high noise coming from the DB room. We know that all electrical equipment make noise. Transformer makes a hum because there's a magnetic restriction. Even capacitors make a noise. Active filters make a lot of noise. So now there are standards available for the building code for hospitals. All the UK hospitals use this, where the ambient noise should be less than, let's say, 55 dB, and you cannot meet the hospital noise standards unless even the electrical equipment there are complying with the noise standards. It's not only the level of noise, but also at what frequency you create the noise. We'll see a little more in detail about this. So this is the EMI EMC. I'm saying any equipment which is installed in a hospital or a high-rise building should have EN 61000 or equivalent certification. That means it's immune from external noise, and it will not create emission which will affect the other equipments. These are two key aspects: immunity and emission, and from both radiated as well as conducted noise. And let's look at the second one, equipment noise level, especially for hospitals. Since there are standards, there are whether you select a transformer or an active filter or a drive or whatever it is, you need to ensure that it does not generate more than, let's say, 56 dB noise. Two, the noise must be at a higher frequency. See, a lot of people do switching at low frequencies, 4, 5, 6 kilohertz. And what you see here is a graph of where the human beings can hear. We can hear from 20 hertz to 20 kilohertz, but the most sensitive is somewhere around 4 to 5 kilohertz. And at that frequency, you create a problem, then the patient in the hospital will be so uncomfortable, right? This is something similar to the flicker problem what we had in the past, that the bulbs used to flicker and people cannot see. It was a strain on the eye. Now we are creating a strain on the ear. So we need to ensure that all the equipments which are put on hospitals and high-rise buildings where there are people living have a very low noise level, and maybe we should have standards for this. Other one is the compartmentalization. So this is a micro level containment. This is exactly like what we do for COVID. The major containment was the cities were locked down, the states were locked down, everything was shut down, but life comes to a standstill. You can have a big fire barrier, but then you should have a compartmentalization or a modularity at the equipment level. Only that particular street is locked down, or only the particular house is locked down, or only the particular individual is locked down, so that the virus or the fire does not spread. So we need to look at every equipment to see whether they are modular, and the defect inside at a local defect is really contained and it doesn't spread. Then this is a very quick summary, my last slide. So hospitals and healthcare and high-rise buildings require power conditioning. They require a lot of power quality. Why? Because they have loads. I mentioned some of the loads, and all these loads, create power quality issues, and they're also very vulnerable to power quality. Number one. So you need to do power conditioning, goes without saying. Two, the safety concerns in these applications are very different from other installations for PQ devices. Why? I cannot do a very simple evacuation. It's very difficult to reach up to the 80th floor and pull a person down, or to go to a ship in the middle of an ocean, or to a patient in an ICU, with a heart-lung machine. To evacuate is very difficult. That means prevention is better than cure. Don't have a fire and then have a fire drill and then safety and all those stuff. Ensure that the fire itself in the first place does not originate. So what is very critical is to select and apply the right kind of power conditioning solution, not just by any active filter. As I said, for the lack of time, I didn't give a case study that the active filter was creating more problems after installation than they had before in this hospital. It was creating so much of a noise. It was circulating a third harmonic current that the entire hospital equipments were malfunctioning. And you also look at the long-term reliability and safety. Some of the very specific requirements include certification for EMI, EMC. This is becoming very, very important, that as the frequencies go up and up, this is becoming very critical. Of course, the equipment should have a very low power loss, high efficiency, and lower operating temperature. This is not only energy conservation. Yes, you save energy when you have a high efficiency drive or a high efficiency transformer, or a high efficiency UPS, but then you solve one problem related to temperature rise and possible reliability and an electrical failure. This is more than pure tariff related benefits here. Equipment should have a wide range of input voltages. Especially in a country like India, it's good to say that the voltages will be controlled. Frequencies in the last 20 years have come a long way. They are very close to 50, they stay there, but in some cases the voltages are still widely varying, but the equipment should be capable of operating under these voltages rather than creating a malfunction. There should be type tested designs, low audible noise, especially for if you're putting equipments in a high-rise building or a hospital, because there are people close to it. Compartmentalized and modular designs. That's about it. I know I really ran through very fast, because I fully appreciate that we are running out of time. So now I would give back to the chair. If there are any questions, I will take it, or we can close my session and go on to the next one.
Thank you very much, Dr. Venkatesh, for a very lucid and informative presentation, particularly with respect to the requirements in hospitals and high-rise buildings. Yes, you spoke about the specific issues related to hospitals where the equipment performance is of paramount importance, and there is high dependence on electrical power. So power quality is very, very important. Same with high-rise building, but in different contexts because of different type of load there. So you have also suggested some specific solutions which are really implementable, and this should be, I think, taken note of. So now we can close the presentations. Mr. Manas, if you allow, we will reduce we have already overshot the time allotted to us. So we would reduce the panel discussion time to 15 minutes, if you agree.
Please, sir, as you feel prudent, and there will be good for the attendees to have their questionnaires interacted.
For that, we'll keep 10 more minutes extra,
Yeah,
differently, separately.
please,
Yeah,
as
yeah,
you feel
definitely.
prudent, no problem.
Yeah. So I'll start the discussions. Mr. Dr. Venkatesh has raised very important issue of importance of power quality in hospitals and high-rise buildings. So my question to him is whether other countries have separate regulations for electrical systems in hospitals and for electrical safety and electrical systems in hospitals and high-rise building. Should India also have specific regulations? Do we have, or what should be done?
Mr. Bakshi, at least for the high-rise building, there's an
Yeah,
international building code, which I just
yeah,
showed in the London fire. There are
yeah.
separate, it's still evolving, but there are separate building codes for high-rise building, and there's a very clear definition of what is a high-rise building, so that there's no confusion, anything about certain level, etc. Purely based on accessibility of the service providers and evacuation. So this is there for the, I would say, the high-rise building. For hospitals, there is a very special document for the
Yeah.
construction of hospital buildings, which
Yes.
also has certain specifics related to the electrical design. I can share these references. I can mail to Mr. Manas. So for hospitals, there's a separate building code, at least I'm aware of. And it also talks about the ambient noise level. That's why I picked up the, so much dB.
Yes.
So to get back to your question, yes, sir, internationally, I believe there are separate building codes for hospitals and high rise. Maybe India should consider adopting it, as appropriate.
I think kindly share these with us. We will take up with the appropriate authorities like Bureau of Energy Efficiency, which is building ECDCs, or Central Electricity Regulatory Commission, or State Electricity Regulatory Commission, or Forum of Regulators, whichever is the proper body for these regulations. We will definitely like to take this further because these are very, very important issues you have raised in your presentation. So
Sure,
this is
sir.
one. Second thing I just wanted to know is how do other countries ensure compliance with these regulations? We have very good regulations in certain matters, but compliance is something
Sir,
we
I
we
can do
always.
this, sir. I can share one note. This is from Abu Dhabi Distribution Company, ADDC. It
Yeah,
started in 2013. It's a very simple APFC panel. In India, it's a cottage industry. There are about 3,000 people who make it. Of course, there is an
yeah.
IEC 61921. There's an equivalent IS. But then they
Mhm.
have fire. They had actually fires coming out of the electrical room. So they
Mhm.
made it mandatory that there must be a type test. Few manufacturers are qualified, and there's a very, very strong due diligence in the design process, and there's a very
Mhm.
high level of standardization. Here in India, you will see there are 3 million types of APFC panels, in shape, in size, in color, in
Yeah,
steps, everything. There they have only
yeah,
5 ratings. I can show you the ADDC website. There are only 6 ratings of APFC panel. They have
okay,
standardized on the rating. They have said for these kind of buildings, for these kind of loads, use type A, type B, type C, or type D. All the manufacturers have type test. And most important, each APFC panel should have an integrated smoke and fire alarm. So inside the APFC, if something happens, that the panel will shut it down first, and there's an alarm outside. So I learned it from the ADDC guys that it is possible, and they learned it by burning the fingers. They had major fires, and then key 3 steps are: one, there is a standardization. This is monitored by the local regulator. Two, not
Mhm.
only every panel is certified by the regulator, and there are surprise checks on installations. They go and check. They go to the utility room and they go and check whether the panels are installed, they are maintained, and they are operating. If not, there is a very huge penalty on the utility manager as well as the guy who has supplied the panel.
Good, very good. But here, if we start something like that, that would amount to some sort of Inspector Raj again. That would create another
I would
more
not
problems
I would
solving
not be
that.
the inspector, sir, but at least the standardization part really helps a lot.
Yeah, yeah,
Standardization
that is
does improve
necessary. That
quality.
is necessary. I totally agree with that. So it is necessary. Yes, sir. Other panelists, if you want to say anything on this or some other issue, we are welcome, please.
Yeah. The last question that you had posed, that how to ensure compliance
True.
of all these things that we are talking about.
Yeah.
And very pertinently, you have asked because you have been in CEA, And
Yeah.
although you mentioned a word called Inspector Raj, but in an evolving third world country like India, some kind of an regulations have to be there in place, and they have to be complied, so that various contractors and various other people who are manufacturing goods and who are installing goods at site, they
Mhm.
need to be controlled, because in a developing in a country, everybody wants to make a fast buck, and
Yeah, yeah.
therefore it is necessary that some kind of a compliance system should exist. Now what is necessary in India is that the so-called electrical inspector, who has been coming right from 1947 when India became independent, how much changes in his profile has happened in last 70 years?
Not
The
much.
electrical inspector continues to be the same electrical inspector. Very few
Mhm.
of them are actually the degree holders, and very few electrical engineers who pass from very good institutes in India would whether ever want to apply for that post.
Yeah.
So
That's
the authorities and the government needs to ensure that a good quality people are put there in position, and they should know what they have to go and inspect. So what the inspector today does is, I do a lot of design of data centers, and we put a lot of high-end installations in India, cost running into crores and crores, and everything that we take care, including compartmentalization, as Mr. Venkatesh was talking about. But the
yeah, yeah.
point is, how much of this is known to electrical inspector? He just comes to inspect, looks for something. Where is your earth pit? If you have shown him 4 earth pits, he would ask for the fifth. And if you have shown him 5, he would ask for the sixth. And
Yeah.
that's where the story ends. So the whole
Hmm.
point is, Mr. Bakshi, is that governments needs to educate. Yes, BIS is writing very good standards. The electrical, code, national electrical code is being implemented and revised now, and Mr. Manas Kundu is forwarding to everybody for inviting their comments and making suggestions. But how much of what is written in national electrical code is actually made mandatory to be read by the electrical inspector? Do they have refresher courses every 3 months or 6 months or even every year to know what changes have taken place and what are the prominent things that they need to go and see at the installations? Unless this is changed, no compliance is possible.
Yes, that's right. Actually, when we were discussing amendment to the Electricity Act, there was a proposal to form a sort of forum of electrical inspectors in India, so that they could meet frequently and interchange ideas and actions to be taken. But that has not materialized. Mr. Mehta had raised a point that third-party safety audits could also help. So I think that is also a good idea if we could mandate third-party audits, say every year or once in 2 years or whatever. What's your say on that?
Yes, sir. In fact, I would just add a small, you know, experience on the first question about compliance to standards. I was in China just 2 to 3 years ago, and part of this APQI's 10th power quality anniversary, session, and it was really revealing in terms of how that country is looking at the formation and dissemination of the standards, whereby they had a workshop planned along with this 3-day power quality global conference that they had held, whereby in that workshop there were parallelly multiple sessions on multiple standards related to power quality. Since it was power quality, so there were multiple standards related to power quality which were being deliberated. Interesting part was the working group members were comprising of almost all the stakeholders which are going to be affected by the standards in the country. So it had right from the utilities to the regulators to the vendors of the manufacturer of the products to the consultants to academic institutional researchers to even the building end user who are going to be affected. So the participation was so well organized, and the standard formation was such a I and Manas, we tried to be present in that room. We couldn't understand obviously anything, but we could make out the sense of the importance that they place on this and the takeaways that each one of us takes out from the sessions, while bringing into the standards, the perspectives of what is important for everyone. So when the formation process involves all the stakeholders, then it becomes a much more serious exercise is what I feel. Whereas sadly today, while BIS is doing a lot of hard work, a lot of good work, but it's
That's
only to the will and the, you know, the I would say motivation of some of people like Manasar and all, that these standards and all are coming out, and it's not an all-rounded exercise. So I think the first place that needs more collaboration, more participation from various strata, various stakeholders. And as far as the second questions are on third party, as I said, my eyes have been opened in the last 5 to 7 years since we have been doing it. There is the biggest problem, sir, is the conflict of interest. What happens is that the audit, the third party inspection is awarded by the very same people who are responsible for installing the installation. So how would you expect the customer to get the right advice and the right feedback on something for which he is being paid for by the installer of the system himself and not by the end client? So if a third party safety audits have to be successful, third party installation audit have to be successful, the end user has to have a say in deciding whom they will be awarding it to. And more importantly, these third party auditors have to be professionally certified. Like in US, they have those professional credits, etc., which are given by NATA and all these organizations, which have a standard refresher courses like Jane sir also mentioned, and that will allow to raise the bar of these agencies and not have those frivolous fly by night operators who are out there to make a quick buck.
That's right. I think that is a good idea that organizations like CEA could empanel qualified auditors, safety auditors. The problem here is in India is that CEA makes regulations. It is empowered under the Act to make regulations on electrical safety or other electrical parameters, but it has no power to implement them. That's the biggest problem. The power to implement goes with the regulator. Then you have to go approve the regulator for getting them implemented. When Mr. Manus would recollect, when we were making model regulations for power quality, the general consensus was that there should be no disincentive or penalties initially. For a few years, we should only focus on this organization implementing the power quality standards on their own without any disincentive or any penalty being levied on them. This is very interesting. We had some Swedish this professor on this committee also, and he told us. I asked him the same question what I am asking here today. How does Sweden ensure compliance of these standards or regulations? They say there is nothing, no incentive, no disincentive, nothing. The government tells this is to be done, this is done. The body complies with that. There's no further need for action. Once it is decided, declared, announced, everybody takes that this is the law. So there's no further action to be taken by anybody. I don't know what do they do if somebody is not complying, but they say normally 99.9% persons would automatically on their own comply with these standards. They just declare the standards, and there is no question of penalty or non-compliance of this. It's understood that this will be complied with. Anyway, any other suggestions on this, sir?
Sir, those countries that you are talking also comply with traffic rules. So those countries are different. Those,
That's right. I'm saying we are not nowhere there near them, but we have to do something to ensure compliance. Simply making regulations, making standards, it has got nothing. No. If we have not been able to ensure that the poor quality electrical equipment is not manufactured in the country, only BIS standards approved things are made. We have not been able to ensure even that. So that is a problem. I agree with that. Another thing I just wanted to raise was in what is the international practice with regard to power quality standard? Yes, sir.
Sir, if I may
Yes.
be permitted, just to add to the previous point.
Yeah, please.
Can I take 1 minute?
Yeah, sure.
Sir, for compliance, I think we should follow the Tokyo Power Company's model, where the Tokyo Power Company, which is a distribution company, has organized to have an independent body of inspectorate, and that is funded by Tokyo Power Company through their tariff mechanism, which is approved. And those inspectors are professionally qualified. They do the inspection as well as they guide every household to
Mhm.
maintain the high standard for electrical safety and to comply with the standards. So something like that institutional building through our distribution companies and the tariff structure, which will be creating that kind of thing, which is at consumers' benefit, can be thought of in future for better
That's good.
implementation
That's
of
a
code.
very good idea, Mr. Manas. Could you make up a small write-up on it? We will take it up with forum of regulators then.
Yes, we'll do that.
Let us write to them. I'll talk to Chairman CERC and let us take it up. Or if CA officers are there, you can send a copy to them also if they have some
Sure.
role to play in this. We can talk to CA chairperson also in this regard. So one more thing I just wanted to know was whether these reliability indices and power quality, these are common in other countries, or reliability indices are separately enumerated and power quality standards are separately enumerated. Is there any sir,
So,
Dr. Venkatesh, could you
sir,
throw
this is
some light?
Venkatesh here. Sir. To the best of my knowledge,
Yeah,
they remind us two independent sets, power quality indices and reliability indices, like
yeah,
SciFi, SciD, all those stuff. They are measured, and power
yeah,
quality indices are separately measured. But then there
yeah.
are utilities around the world. For
Mhm.
example, 20 years back, New Zealand Electricity Authority, they started publishing these actual parameters in their annual report, and it is there in their website. They not only
Okay.
measure, it's like a balance sheet of a company during the AGM, they put it in the annual report. Maybe this we can mandate, not all the parameters, maybe we select certain parameters, both the reliability indices as well as the PQ indices, and we can
Mhm.
tell all these discoms that they should publish it so that it's very transparent and people will know where they are. And they also track quarter on quarter, how do they improve. It's like a typical private company reporting results quarter on quarter or annual.
Yeah, yeah, that's good. Good idea, sir. Anyway, sir, is there anything else, sir, you would like to say, or we move to the question answer session now? Mr. Manas, we move to the question answer session.
Yes, I think
There are any?
that's better, please. Yeah.
Yeah.
We have received a lot of questions. It's difficult for us to go through each and every question and then answer those questions. Uh, we will be
We
sitting
can
till morning there.
we can answer them later by email or something. You can take 2 or 3 very important questions you
Yes,
think are
I
important.
think Mr. Rajan Mehta has already done his job by answering most of the questions which is asked to him directly on the question itself.
Okay.
I'll try and take 2 3 key questions, and then what I suggest, we will share the questions with all the panelists
Yeah,
who
yeah.
can
Okay.
answer them and reply us back, so that when we send a report to all the attendees, we will
Yeah, yeah.
send the
Okay.
answers to the questions as well, so that
Yes. Yeah.
attendees
That's
should not
nice.
feel that they were bypassed and not
Ignored.
answered to that
They've
question.
been ignored. That's right. I agree.
Fine, sir. Yeah.
Thank
So
you.
I'll quickly take a couple of questions
Yeah,
which
please.
are there. Just a moment now. Okay. There is a question from Mr. Mohan Paranspe, that is filters to prevent harmonics entering the supply side. Calculations are necessary for sizing filters, especially CT scan, MRI, gamma ray equipment. Are filters available of large sizing? And this question goes to Dr. Venkatesh.
Sir,
Kindly.
yes. All these equipments, there are two ways. Either you can make measurements, or if you go to the supplier of the equipment, they will give you what kind of input power they draw, be it a CT scanner or MRI. So you can either do it for the individual equipment, which I don't personally recommend, but if there are a lot of equipments on one feeder, you can calculate the height, the size, and the configuration of the power conditioning equipment required, which are feeding these healthcare equipment. Yes, it's possible.
Okay, say again a question to Dr. Venkatesh. A question: electrical safety in operation theaters, ICUs, ICCUs in any hospitals in India is not up to the international standard practice. What, according to you, where is it? What according to you is the difference between the standards which we follow in India and the other developed or advanced countries?
See, this I really won't know, but I know for sure that there are international standards. And maybe I've been to hospitals which follow. Maybe even other countries, there could be some hospitals which don't follow. So I will not get into India and foreign who has got a better compliance. But generally, there are standards for hospital buildings, not only electrical, the complete hospital building in terms of evacuation, in terms of safety, in terms of noise level, in terms of patient care, everything. And the only difference I find that in a foreign country, the regulations are followed both in the word as well as the spirit of it, right? The word and the spirit. Whereas in certain countries, especially in India, where healthcare is not so well regulated and it's more business, maybe one of the reasons why the word and the spirit of the regulation is not followed, and we end up with some kind of a compromise. But this I really won't know. I mean, why some people follow and some people don't follow. But there are standards, and everybody can follow, and everybody is expected to follow.
Okay. For understanding of the audience also, there is one already IS standard is under development on the electrical installations in hospitals, and that standard is expected to be released by at least end of this year or start of next year. So we will be at least having some standards in place as far as electrical installations in buildings are concerned from BIS. That is Indian standards we can talk about. Okay, thank you very much, Dr. Venkat. The next question is to Mr. Bakshi, sir. Uh, Possibilities of brownout in low voltage, that is 450 volt or 230 volt network, and its impact on electronics. Valuable insight on CA notification on power quality release in February 2019. You have any comment on this particular question?
No, we are just studying it. I have to discuss it with Mr. Maske. Yes, I have seen that, but I need to discuss it with them in detail. Yeah. You remember, if I can just want to tell you that there is a technical committee of CERC also, so which is coordinating the activities between CEA and CERC. CEA makes technical regulations and CERC ensures proper regulations and implementation of them. So I am still, even after retirement, I am on the technical committee, and we will take it. Kindly give us some time before we form a firm opinion on that.
Okay. Okay, thank you very much, sir. I'll take a last question to Mr. N.K. Jain, sir. There is a question that a size of bus duct designed to carry correct amperage is too high when the buildings are uh, 40 meters and more height. Is it not desirable to place transformer closer to load, maybe at different level? So what is your comment on that, sir?
Yes, if buildings are very tall, like in Mumbai, we have now buildings which are as high as 100 floors, and even those are residential buildings. So in such buildings, yes, it is desirable to locate the transformers at higher floors. And as Mr. Venkatesh was telling that, the HT cables are taken right up to those transformers, and every segment of 10 floors or 20 floors is served by a transformer which is located at that floor. And it's not really possible to run a bus duct from ground floor to the 100th floor or even 40th floor or 30th floor. So bus ducts are run only to certain level, and then another bus duct is run from there. Or if design does not allow for transformers to be kept at higher floor because of the floor loading, the transformers are very heavy equipment. Each transformer could be 5 ton or 10 ton. So if the building is not allowing such kind of a high loads to be kept there, then also the bus ducts are kept at lower floor. but for every 10 floors or every certain number of floors, a bus duct is used, and then for the next floor, another bus duct is used, which is not tapped at lower floors. So there are various ways to manage these things. But yes, primarily as the buildings are going higher and higher, the transformers have to be located above, and even the metering rooms have to be located at every 10th floor or every 5th floor.
Thank you very much, sir. So with this, I think we'll sum up our question answer session. And once again, apology to the other participants who has raised the questions, but we because of lack of time, we won't be able to answer them in this session. But of course, as we discussed, we will share the questions with all the panelists. We will take the answers from them, and when we share a report, we will definitely share the answers to your questions as well. So with this, I'll take a pleasure and honor again to do a small word of thanks from my side. I would like to thank the chairperson for the today's event, Mr. Bakshi, for sharing his valuable insights and taking us through this webinar. I would also like to thank our panelists, valued panelists, I would rather say, who has spared their valuable time to do a enlightening presentation today. Mr. N.K. Jain sir, Mr. Rajan Mehta, and Dr. Venkatesh for enlightening us on the impact of power quality on electric safety. There is a lot of confusion in the minds of the people that power quality is a different topic altogether and electrical safety is different topic. So people always keep their in a compartmentalized position when we talk about power quality and electrical safety. But today's session, I think, was very important for the people who are the installers to understand that yes, power quality is mostly related to electrical safety, which we got a decent knowledge in today's session. I would also like to thank Mr. Ravindra Gupta, Chief Engineer, CA, and Chief Electrical Inspector to Government of India. He was there for some time, but need to leave for some meeting, so he need to leave. But then I would also like to thank the team members from CEA, whose continuous support help us to conduct this successful event. I would also like to give a special thanks to EMA for their timely support. I would like to give a special thanks to Mr. Manas Kundu, who helped us to get all these stalwart, we can say, panelists today on a same platform and make a grand success as far as delivering the knowledge on electrical safety and power quality is concerned. Last but not least, I would like to thank all the participants for their valuable time, spending their valuable time, and hope you all had a great session. Uh, I hope we have not exceeded much of our time, but yes, this much time is actually required to gain a lot of knowledge in this very limited time. So, hats off to all the panelists who manage their times and try to give maximum knowledge, or rather deliver maximum knowledge what they can do from their end within a restricted given time. If any of our questions has remained unanswered as we discussed, we will email you all the answers to your questions when we submit our report to you. And uh, as far as report is concerned, we will try to send you the report for this webinar along with the presentations, possibly next 3 to 4 working days time. So with this, I would like to say that today's session is concluded. And once again, thanks to all the panelists and the dignitaries present on the dais. Thank you very
Thank
much.
Thank you.
you.
Thank you.
Thank you.
Thank you.
Thank you very much. Thank you.